Hi, well, good evening, everybody. I'm really excited to speak with all of you this evening. Thank you very much for your interest in the just go down, I'm going to hear a little bit of a fear. So, I am a local, I was born and raised here. I'm currently working as an entomologist in San Diego. But as a swim through my life here, exploring the desert, it was been entomology class at IVDM, transferred to the University of from the Riverside, where I got my bachelor's and PhD in entomology. And after that, I moved to San Diego for my master's. So the purpose of today's presentation is mostly just to give you a greater appreciation. Obviously, all of you are here today because we appreciate the event Southwest to extend into our region here. So I'm hoping to provide you with some more information on some of the unique critters we have. Okay, so just a bit of an outline today. We're going to start off giving you an idea of where arthropods are ranked in all the other organisms. The arthropods that are living in such a dry area environment obviously have certain adaptations, whether they be behavioral or morphological, according to the species and characteristics of the bodies that are also physical in this type of environment. And then I'm going to introduce you to some arthropods that you may see on some of the hikes, perhaps you know, so depending on the hikes. Maybe you've seen some of these arthropods before. If not, then you'll recognize them next. All right, so just starting off with the taxonomic ranking system. Some of you may be familiar with this cataloging here: kingdom, phylum, class, order, family, genus, and species. Starting from the top, the kingdom is the most broad, and in this case, this includes all of the animals. So insects and other arthropods fall into the animal. And the arthropods fall out in the phylum category. So what else is included there? Are not the only ones. You have crustaceans there. These include crabs, lobsters, barnacles. You can have Arthropods, centipedes, millipedes, arachnids, spiders, scorpions, minnows, and of course insects. But the purpose of today, we're going to be focusing on the terrestrial. And then say you wanted to finish that classification. Going down for this specimen here, this butterfly, insects come out under the class level, Insecta. The order is Lepidoptera, that refers to moths and butterflies, a specific group within insects. Further down, it gets more specific. Pearity refers to the sulfurs, so the butterflies that are yellow, sometimes they can be a bit white. The genus is Polias. When you see the genus listed, it's always italicized. And the species is Polias ranking, again italicized. So just to do the same thing, to give an example, for humans, we call it animals as well, but we are separated at the phylum level, Chordata, and that's due to certain characteristics. We have certain developmental systems, starting from the embryo. If you want to go on down the list, then you end up with Homo sapiens. Okay, so now that we've determined what an arthropod is, what are some of the characters that put them in that group? There are 5 that I want to introduce you to today. Right? Yes. Yeah. Okay, let me just talk about it. Can you hear me okay? Yeah. Yeah, I was hearing an echo.
Just need to speak up a little bit in the back here.
Okay, so the 5 characteristics for arthropods. The first one is exoskeleton. You're probably familiar with term that's in reference to the outer hardening of their body. Humans have an internal and external. Arthropods have segmented bodies, so insects specifically have three main body parts: the head, or spiders can have different numbers. They have two, like head and thorax region, and then they have two. Bilateral symmetry is another character that you see in all arthropods. Where you take a line and separate it down the middle. It would use the same characters on the left side as you do on the right side. And when you look at collections, and then tend to look at the insect collection, take a look into the pin is located. The nervous is to the right of the midline. And that's necessary because sometimes arthropods have certain patterns that are diagnostic and very complicated. If you were to put that pin along the middle, you might be obscuring an important character. So by placing it to the right of that midline, you'll see that character on the left. Arthropods also have jointed appendages. This is really the translation of the name Arthropoda. Arthro referring to jointed, and pod means foot. And an open circulatory system. So unlike humans, insects, their hemolymph, so their blood, is circulating throughout their body, and it's not carried to tissues and through arteries like it is for us. Their respiratory system is a channel through the tissues. But the blood is essentially circulating freely through the body, and it transports nutrients as well as waste. Okay, so what are the strategies for survival for these arthropods? So the first one is coloration. So this is typical for insects, not just in the desert, in other habitats. You can also see different types of coloration that indicate different things for other animals or different plants. So the first one I want to point out is Cactus, is seen by this desert bush Riva cricket. I heard one just outside of some of the tree folk. We have a cookie. Next time you're out here, take a listen. The territorial, and they'll each male will be in its own bush trying to attract the female, and put the males to let the other males know that that's its territory. So you'll notice it's blending into this tree folk pretty well. It's pretty difficult to spot. Aposematism, as seen by this tarantula wasp here, and puppy. Aposematic coloration refers to coloration that is bright red, bright black, yellow, orange. This gives a warning to predators that they are unpalatable. So either they have venom or they're not good to eat. So some insects will accumulate toxins. The caterpillars will be toxic plants accumulating that in their bodies. Toxic to any predators that may want to see. The next one down here, heat absorption. There are a couple of beetles in the desert that you can see black coloration. That's thought to aid acquiring energy that will help for locomotion. And then heat reflecting coloration. So these white colors will reflect the light. They won't overheat, especially if they're out during the warmer time of the day. Activity patterns is an important thing for desert arthropods as well. Typically, you'll see these arthropods out about foraging at dawn and dusk. A lot of them take advantage of nests in the ground, which are essentially hunker down and burrow until it's cooler. And then, of course, we have insects like moths who come out in the evening in search of damaged or, the fruit in this case, you'll often see insects taking advantage of that resource. All right, so let's just go through those 10 arthropods that I wanted to mention. And just talking about the title, I mean, you can probably guess why I chose the title. Thinking about the desert Southwest, it reminds me of the Western movies. So the good, a lot of the insects that I'm going to be discussing today are native species to the desert Southwest. They all serve a purpose in this environment. They all fit some role. The bad, this is an agricultural county, and so towards the end of the list, I'm going to mention 2 agricultural pests of interest. And then the beautiful, in my opinion, I don't find any arthropod ugly. I know some of them look unusual and the features that they have are pretty bizarre, but each of those structures serves a purpose and it allows it to survive. Okay, so taking a look at this picture here, can somebody tell me something unusual in this? This is a creosote bush. Is there anything unusual that you notice in the image that stands out to you? I don't know how difficult it is to see. Okay. Yeah, good. So you guys are, have you seen one of those before? When you're out walking around? Have any of you spotted that before? No. Okay. This one was taken right outside the museum, this image here. The next time you go out, I'm certain you'll spot them. Once you have a search image, you'll see them again. These are actually galls. So it's basically a benign tumor that's grown on this creosote bush in response to insect feeding. So galls can be found on various types of plants. They can be found on the leaves, stems, the fruit, the buds. In this case, this is a gall that was induced by a tiny fly called a midge. And what happens is the female will find the creosote bush, lay an egg, deposit some fungus there. The combination of that insect wound as well as the fungus causes the creosote bush to produce an abnormal amount of tissue. It's basically enveloping that insect, similar to a pearl, for instance. It's meant to protect the plant, protect that wound, but what it's actually doing is providing a safe habitat for that larva to develop. So the larva consumes that abnormal growth from inside, and it's safe from predators. And there are about 15 or 16 species closely related that will take advantage of these creosote bushes. The next one is the Jerusalem cricket. I don't know if any of you have seen these before. Usually they're underground eating roots. They'll also eat insects or decaying vegetation. They're known, well, this is about the size. To give you an example, this is my hand. I found this one in my yard. And they're also well-known diggers. They're excellent diggers. In order to be able to go under the ground to get to those roots, they have these modified forelegs, which are termed fossorial. So you can see they have these large spines right here that really aid in that digging. They're very unusual. They are related to crickets and grasshoppers, but they don't develop wings. So this is a mature adult, and it doesn't have any wings. It also has this large head, which kind of gives the following common names. So one of the common names is Niño de la Tierra, which means child of the earth, or the Navajo word Huatzine, which means old bald-headed man. Skull insect. They've also been called potato bug or devil's baby.
I noticed you've got a glove on. Was that it's not a good thing to hold in your skin?
No, so I was working with the shovel when I found it. And that's you brought up a good question too. So these are not venomous. They're mostly harmless. They will bite. They have mandibles. And if you do get bitten, it will hurt a bit, but that you don't have to worry about that. If they're handled carelessly, then it may bite you. All right, this is one that I've seen a lot on my hikes. This is a darkling beetle, a type of darkling beetle. It's also called desert stink beetle. or Penicate beetle. The word Penicate comes from a Mexican word in the language of the Nahuatl, which is pinacatl, which literally translates to black beetle. These ones are known for the defensive posture. When disturbed or threatened, they'll basically do a headstand with their rear pointed up in the air, and then they'll emit some kind of noxious spray. Now for humans, it's not gonna, you may not be able to smell it very well, but for smaller vertebrates that are gonna eat them, then it's pretty unpalatable and it may cause some discomfort. However, there is a mouse, a grasshopper mouse, that has gotten around that. And what it does is it'll come up to one of these beetles and it'll stick its rear end in the sand and then consume it from the head down. Okay, this is a beetle that was depicted earlier. This is a very common one in the desert Southwest. It's called an inflated beetle because of its inflated dome-like elytra. It's basically dead space, dead airspace between those hardened wings and the rest of its body. And the purpose of that is thought to be temperature regulation. So regulating its temperature, like insulating its body. These ones like to hang out in creosote. They can be found, so on creosote, they'll eat the leaves. The leaves of creosote provide a lot of water for them. And that's important because these guys, unlike other desert arthropods, are active during those warmer parts of the day. And that's usually because they're after flowers and nectar. Okay, then one of my favorites, harvester ants, otherwise known as the bearded ladies of the desert. They're called bearded ladies because they have these hairs underneath their head. And the purpose of that is these ants are known for not just harvesting seeds, but for their extensive nests that they build. And they typically build these nests in sandy soils. And in order to build your nest there, you got to excavate all of that soil out. It takes a lot of work and a long time for such a small insect. So what they do is they'll grab a pellet of soil with their mandibles, but their mandibles can only hold so much. Especially those finer size particles will fall right out of their mandibles. So by having that extra basket of hairs there, it allows them to scoop up and hold a greater portion of material. And that hair there is called the semaphore. So here's some examples of some of their nests. This is a younger nest. You can see it's recently been excavated. It has a lot of soil, kind of mound-like around the outside. These arrows are pointing to their refuse piles, otherwise known as midden piles. They'll have the, so they're harvesting seeds predominantly. They'll keep the portion of the seed that has the protein in the nest, and after it's consumed, they'll discard of the chaff outside of the nest in these piles, away from the opening. This is a more mature nest. You can see it's been cleared. That's typical for these types of ants. There was vegetation here at one point, but they will clear it completely. Sometimes you'll also find discarded ants, maybe some that were sick, or maybe they got into a fight with a neighboring colony. Sometimes there's battles between these ants, or other debris. These are some that were taken outside of my home in San Diego County. You can see they're carrying a large seed here that hasn't been consumed. Some of them will hang out at really anything that's available in the environment. And this is a midden pile of the California buckwheat bush. The next one is a beautiful insect. They look very beautiful and cuddly, but I caution you against handling these ones. They are, again, you'll see that aposematic coloration, that warning coloration. These ones pack a very painful sting. They're called velvet ants because they look like ants. You can see these two here that don't have wings. The females don't have wings, giving them that ant-like appearance, but they're actually wasps. So they fall under the order Hymenoptera, which includes ants, bees, and wasps. The males, on the other hand, do have wings. And you can find them out in the environment, even during the warmer parts of the day, feeding on nectar, sap,
from various plants. Some of them, such as this one or the one that I showed earlier, that other bright white one, will mimic creosote bush seeds. And when they're scurrying along the desert floor, some people have said that they look like a creosote seed blowing in the wind. All right, the next one. This is an arachnid.
So aggressive.
So these ones are called wind scorpions because of their fast movement. They run very fast at really fast speed along the desert. Sun spider. Most of them, at least here in this area, are only active during the dawn and dusk portions of the day, but there are some places around the world where they've been seen scurrying around in the midday. So these are present worldwide in arid environments similar to ours. Africa is one place that you'll see a lot of these. So they have the eight legs that are typical of arachnids, but they have modified pedipalps here. So for other arachnids, they'll have these small feeler type appendages right underneath their mandibles. These ones are greatly elongated and they serve as antennae, basically. They have these large chelicerae that are scissor-like for cutting up their prey. And then just to give you an example of their size, this is my thumb. And here's one that I found in my garden recently. You know, they look aggressive and they look scary, but again, they're pretty harmless unless you handle them carelessly again. And they're important. They eat a lot of different arthropods and pest species.
So they have a stinger on them? Yes.
No, they do not have venom. Yeah, these do not have venom.
So they're an arachnid.
Yes, they're a type of arachnid. Yeah.
So their best defense is their wings.
Yeah, so their strategy is to run very fast, and then you know you just use their when they catch something, just chop it up. Okay, do you have a question? I suppose larger lizards could eat them. A snake might eat them. A bird. They'll also eat, in addition to smaller arthropods, if vertebrates are small enough, tiny frogs or tiny lizards or tiny birds, if they can get a hold of, they'll eat them too. So it goes both ways, I guess. Yeah.
Are they web spinners?
No, no. So they're not true spiders. They're related to spiders in that they're arachnids, but they're a different order. So they're just as related to scorpions, for instance, as they are to spiders. Okay, the next one is a cochineal scale insect. How many of you guys have seen the Opuntia prickly pears growing out there and seen a bunch of white fuzzy stuff on it? Yeah, okay. So the prickly pear cactus is native to the southwestern United States. You'll find it in Mexico and Central America as well. And there are insects that have adapted to feeding on these pads. And what they are these globular looking things that don't even really look like an insect, right? So this is a female, an adult female. Her mouth parts are here and her tiny legs are sticking out. This is looking ventrally at her body. This is an alcohol. So this is basically what she looks like in picture form. And the males have wings, the females lack wings. And the females will just develop here. So starting from an immature, they'll grow and they'll just remain on that plant for the duration of their life. The male will find the females, mate with them there on the pad, and then they'll produce offspring in large numbers. And then those offspring will grow up and eat the plant with her. So you can get large populations growing on these prickly pears in quite a short time. So the interesting thing about these here is the substance that's present in their bodies. It's a chemical called carmine, and the natives that have lived here in this area have been using this carmine to dye their clothing for hundreds of years. So there's some interesting history behind here. You can see an individual collecting the scales, scraping them off of the pads. And what they'll do is they'll collect them and then they'll leave them out to dry. And then once they're dried completely, then they'll crush them up and maybe add a bit of water or whatever they use at the time. And then they'll use that to dye. They'll put their clothing in there and let it soak. So there's a lot of interesting history too about this dye. In the 15th century in Europe, textile industry was big, and they were looking for the newest thing to dye their clothing to produce the brightest color. So some Spanish explorers came here and they discovered that they were using something to dye these materials, and they realized it was the insect. So then they started exporting this to Europe. And then there was a lot of competition going on in Europe between these different textile businesses, also between countries. And the Spanish tried to keep it a secret as long as they could, because they wanted to be the only ones producing that bright red. And eventually it was found out. And, you know, currently we have cheaper synthetic options, but you can still find it in beverages. So the next time you're picking up a pink drink, check the label to see if it says carmine or cochineal extract.
Are these companies then harvesting them, growing their own?
So that's a good question. I don't know. So it takes a lot of insects to make that. I know that there are certain places still in Central America where there are farms, cochineal farms, where they're doing that specifically. As far as these companies, so I know Starbucks had this in one of their drinks before the public found out. And then the public found out, and I guess they got grossed out because they were insects. However, I think it's a better option. You know, I mean, it's a natural option, right? And really, you know, in our food, you can't really escape. You know, anyway. Yeah, so I'm not quite sure who is producing that or where that's sourced, but I'd imagine that sure, yeah, someone probably has a farm of the cactus and they have insects on it. It seems very laborious though. So I'm not sure how it works today. All right, so now we're gonna go, the last two are some agricultural pests of interest. So one of them is actually a native species that I'm gonna show you now. And the next one is an invasive species. So just to give you some comparison. This one is the orange sulfur, otherwise known as the alfalfa butterfly. It's a Pear. It's the one that I showed you earlier when we were going through that taxonomic classification. But before I go into it, do any of you guys know what the California state insect is? The California state insect. No? Yeah, so that's the so that's the hint. It is a very similar looking insect to this, and the reason I mention this is because people will often get these two confused. You can see their coloration looks very similar. They're in the same family of butterflies, the sulfurs. But this one, our California state insect is called the dog-faced butterfly because the forewings have this, what looks like kind of like a poodle, people have said. And you'll see this one, its pattern looks pretty similar. It kind of looks like it has some faded edges. It has a spot here, but it doesn't have this distinct dog face marking.
I think California, the alfalfa butterfly locations on the front of your grill.
Exactly. So,
Mine's on the register.
yeah, exactly. So that's part of the reason why I chose this one today, because I'm sure all of you guys have seen this summer. These ones are active from May through October. You know, flying over the A freeway there in search of alfalfa and other things to eat. So they vary really, and they're called an orange sulfur. They can be a brighter orange than this. A lot of them have this yellowish color. Some can even have a lighter, almost white color. They're all the same species. So these ones occur in North America, from southern Canada to northern Mexico. And so this is one that's been here for a while. Did you have a question? Oh, sorry, that's okay. So this is what the larva looks like. And the larva, of course, for butterflies is the one that does the damage. They will feed on various types of pea plants, but when alfalfa is available, they will consume that. And for the most part, they're not a huge problem, but like any agricultural pest, when the numbers get to a certain level, then the damage can be quite extensive. These ones will consume the entire leaf. Some caterpillars will skeletonize leaves. They'll just consume the softer part and leave the midrib that's holding the structure of the leaf. These ones will consume the entire leaf. And I wanted to mention these ones here because you've probably all seen them, but also Imperial County, one of their main commodities is alfalfa. They produce a lot of alfalfa for hay, which feeds the livestock here domestically. They also export it to Northern California, to other states around the United States. I'm living in San Diego. I have goats, and I know that I've gotten some of the hay from here. And they'll also export it to China and other areas around the world.
When you see crop dusters, are they primarily going after that particular species?
What was
Crop dusters, when they're flying and eradicate and spraying?
Oh, you mean the airplanes spray? They could be. I think, well, so we'll talk about the next one too. It could be, it depends on the field, what the crop host is. There are various arthropods that are present within a given field. I don't know that this one is necessarily a big problem for the farmers here. It's present just during a certain season, from that May through October. There's not any huge news about this, and this one too has natural enemies that keep its levels at a probably at a level that's not really having a great economic impact. And that's typical for insects that are from this area. They're just taking advantage of the alfalfa that we're growing here. So in contrast to that, I want to introduce to you an invasive agricultural pest. So I don't know if you guys have heard about, well, first of all, show of hands, how many of you guys have seen these huge white clouds, flying around? Yeah. Yeah, so that's one of my earliest memories, insect experiences growing up here. I remember as a kid, I was telling Hannah that when I was a kid, I was playing outside with some neighbor kids, and there was this huge cloud of white that started coming by. My mom called us in, and we were just looking out the window, and you couldn't see anything. It was just a blanket of white. And so what that is these whiteflies. These are less than 2 millimeters in size, but they feed in large numbers. So this was a clipping that I took from the Los Angeles Times from a report in 1992. And they mentioned an invasion of Poinsettia whitefly. And that was because there's a species of whitefly that was an occasional pest of cole crops. Cole crops include broccoli, cauliflower. These whiteflies will also consume lettuce, melons, things like that. It was occasional pest of cole crops. It was called Penicate tabacea. However, in Florida, in 1986, they noticed that what they thought was Penicate tabacea was starting to attack other crops that it hadn't previously, such as the poinsettias that were grown there. And then they were noticing virus symptoms in some of the crops, the tomatoes and the squash. And they were wondering, okay, well, what's going on? So they termed that insect, Penicate tabacea, biotype B. They thought it was just a different strain of that whitefly. It was also resistant insecticides they've been using. So it was really devastating the crops there in Florida. It then made its way to Texas, did some damage there, and it arrived here in California in 1990. So by the late summer of 1991, its populations had peaked to the extent that it was noticeable here in Imperial County. And that was just in time for those winter crops. So by the end of the summer, then they start Those winter crops into January of the next year are growing. All of those winter crops, those cold crops, the vegetables, some tomatoes, and it was really devastating, the stuff that they were producing here. And so then in 1991 and 92, there were a lot of reports coming out trying to figure out what it was, why it was acting this way. It seemed to be doing more damage than the other one. And what they found out was actually a different species altogether. They don't know where exactly it came from, how it got here. They suspect it maybe came from the Middle Eastern area. Yeah, so it was very devastating. This is an adult whitefly. They feed by sticking their proboscis into the plant and sucking out the juices. Again, one is not going to do much damage. Of course, it's very tiny, but they reproduce in large numbers. The nymphs will also feed on the plant. So those are the immature ones. It got its name. So this new species that was discovered is termed the silverleaf whitefly. Some of the damage that it does on squash plants, it'll cause a separation of the epidermis of the leaf with the lower cell layer. And then when light reflects off of it, it gives it a silvery sheen. So any damage that occurs to crops, the leaves, will result in damage to the fruit. Usually that's like a source of shade for the fruit, so it can cause abnormal fruit. In general, it was causing lower yield. It was disrupting the development. They also produce sooty mold. That's this black substance that grows on the surface of the leaves. It's typical for any sap-sucking insect that consumes sugar from plants. So what they'll do is they'll consume the sugar, and then they'll excrete droplets of the sugary substance. It's basically fecal matter, but it's very sugary, high in sugar. It's sticky. It sticks to the surface of the leaves. That sticky substance will collect debris blowing in the wind, and it'll also attract the development of fungus. That together causes this black mold to grow on the surface of the leaves, which impacts photosynthesis. So the plant is not able to get what it needs from the sun. And in large numbers, that'll coat a lot of those leaves. And then currently, the county is really interested in controlling these whiteflies too, because they, like I mentioned before, they've introduced new viruses to some of the crops here. So there's a tomato leaf yellowing curling virus that causes discoloration and abnormalities in the tomatoes. And so, this is just an example of what can happen when an invasive pest arrives. Basically, for this insect, it was escaping its natural enemies. It has natural enemies that keep its populations at a level that's manageable in its native range, but when they come to the new area, if they don't have natural enemies or things keeping them at a minimum, then they can do some damage.
So I remember the great 1990
Yeah.
invasion too, and they were trying to. I remember they discouraged hibiscus. It seemed like it attracted hibiscus. It's kind of hard to buy hibiscus here at the nurseries and everything.
Okay.
But did they get that under control? The whitefly? I still see problems.
Yeah, it's still a problem. Insecticides it's hard to control with insecticides. These insects will feed on the underside of the leaves at the lower portion of the plant. And so when, like you mentioned, those crop dusters, when they're going over, they don't really get at the source. They're kind of protected under that lower level. What they're doing now, they're testing some things out with biological control, which is the use of natural enemies that are present, and also introducing other insects from their native range to try to control them. That hasn't been as successful. So what they're doing now are cultural control practices, so management practices, making sure that after they've harvested, clean up all of the material completely so that there's nothing available. Sometimes they'll wait a certain period and not grow, to try to get the population to die down. That's basically what they've been doing now. I imagine some people are also working on developing more resistant strains of these crops as well. But yeah, it's definitely a battle. And the interesting thing about this too is there was a whitefly that was present here, like I mentioned before, that was an occasional pest. That one's been completely displaced. So this invasive is the only one that you find now, and you can't find that other one. Yeah, right. Yeah, at the time it was a huge problem for the field workers. They were almost breathing them in when their throats were getting irritated, so they had to wear masks. And so that concludes my presentation. I just want to mention some resources that I encourage you to look up. These are good resources for identification, or if you enjoy going out and taking images. These are public websites that you can use. Bugguide.net is one that's used by both amateurs and experts. iNaturalist is a good one. Some of the images that were in my presentation were photos that were taken by people going around the Imperial Valley and taking images. And then the UC-IPM is the University of California's Integrated Pest Management website. They have very useful information that I recommend homeowners, gardeners, even commercial growers use. So they have a list. You can look up the plant you're interested in. Say you're gardening tomatoes. Go ahead and look up tomato in there, and you can see a list of pests that are listed under tomatoes, insects, mites. What are the type of diseases that you might see on a tomato? They have excellent images for you to identify and figure out what you're dealing with. And then just some image credit. A lot of the images were taken by me, otherwise noted. Thank you. It should be connected still.
So I'm Hannah, and I've got a bachelor's degree in ecology and a master's in entomology from the University of Florida. And I'm working in entomology right now in Calexico. I'm new to the area, so it's been fun kind of learning about the insects around here and the history. And I'm really gonna kind of plug an event we're doing tomorrow at the museum. And I think it's gonna be a lot of fun. It's a free family event, and the USDA is going to be taking part in it. There'll be a lot of activities for kids and adults, and I'm most excited about the blacklight trapping we're going to do to attract insects, and that's pretty much what I'm going to talk about for the next 10 minutes or so. I'm going to pull back from the kind of hyper-local perspective we've been taking most of the evening. So we can look kind of at the broader pieces of insect diversity. I'm going to talk a little bit about vision and navigation, and then explain kind of how that ties into the collecting technique we're going to be using tomorrow. This chart isn't completely accurate, it's outdated, but it gives you a general idea of the spread of biodiversity on Earth. And you can see that a tremendous amount of the known species on Earth are insects, and that number is about 900,000 right now. And there are many more for sure that we have not yet discovered. So that makes up about 80% of all the species on the planet. It's an incredibly diverse group of organisms. And from the Smithsonian, At any one time, it's estimated that there are 10 quintillion individual insects alive, which is a 1 followed by 19 zeros. And other figures are there are more than 200 million insects per person on the planet, or 300 pounds of insects for every pound of human. So they're incredibly diverse, and it's often reflected in their highly variable bodies and capabilities, their physiology. So insects live in almost every habitat on Earth, and each habitat has different environmental features that the insect needs to interface with. And the different environments have driven different physiological adaptations that kind of allow the insects to thrive in those particular environments. So as an example, if we look at insect wings, right, most adult insects, we saw some exceptions, have 2 pairs of wings, front wings and hind wings. But there's a lot of variety in the structure and function of those wings. And you can see, the wings of a honeybee, which we're all probably fairly familiar with, so I can, right? Very the wings of a beetle. And, honeybees, they need to be accurate, strong flyers to do what they do, to scout for flowers, to collect pollen, to fly back to the nest. And they are excellent flyers. With beetles, the front pair of wings, right? We talked about this a little bit earlier. They're not used for active flight. They're hardened and protective. We call them elytra. And they kind of sacrifice excellent flight, right? For flight that's good enough and extra protection of their hind wings. So I'm going to show you this slow motion video, hopefully, so that you can see how the wings are used for flight in a ladybug or ladybird beetle. And, the part that we see, the colored part, those are really the front wings. They're just modified. And as Deb mentioned, when they're getting ready to take flight, they'll kick those front wings up and unfold the back wings. And then rather slowly and ungracefully take off. And it's good enough for what they need to do. A little ridiculous, but perfectly functional. Yeah. So as with the variation in wings, right? Different types of insects have different types and shapes and even numbers of eyes. There's a tremendous amount of variation. And we don't know everything about insect vision or how it's used for navigation, but it's been studied a lot, and we do know some things. We know for sure that some insects can see 3-dimensionally, like this mantis here, sporting the 3D shades. We know that some insects can navigate using celestial objects, so the sun, the moon, and stars. And we know that they can navigate using polarized light. So when there's cloud cover and they can't use the markers they typically use for orientation, they can still navigate using a different type of light. And we know that they can see higher into the light spectrum than we can. They can see ultraviolet light or UV light. And this is just a visual representation of the differences in visual light that humans can see and bees can see. And there's a lot of overlap. But again, the bees are seeing further into the spectrum, into the ultraviolet spectrum. And let's see here. This is how that translates into the real world. So each of these pairs of photos illustrates the difference in what we see versus what an insect likely sees. The images on the left, that's what you see in your yard on your walk. And the images on the right are what these flowers look like if you can see UV light. There are special cameras and filters that are used that are sensitive to UV light that are used to take images like this. And you can see, right, in the UV light pictures that with the UV light, you can see these patterns that seem to indicate that they would be drawing insects in towards the center, right? Which is where the plant's reproductive parts are, which is where the pollen is, which is where the nectar is. So the insects are guided to their food source and the plants are getting pollinated. And this is how we're going to exploit their ability to see UV light tomorrow. These pics are from 2 different night collecting events that Deborah and I took part in over the last few weeks, all within a few miles of the museum. And, you know, we wanted to do a test run and see kind of what we might find at an event like this at this particular time of year. And the setup's really simple. You get a black light, which emits light on the UV spectrum. You hook it up to a power source, typically an external battery, or you can get ones that plug into your car, like your lighter port, if we still have those in cars these days. And you place that light near or on a white sheet, which serves 2 purposes. It's reflective, so you're broadcasting more light, hopefully attracting more things. And it also gives insects a place to land and for us to look at them and collect them, if that's what we're doing. You know, the sheet can be on the ground or vertical, and we'll have a couple of these set up tomorrow night. And it's supposed to be a full moon and clear, which is never ideal because you don't want to compete with that light. But I'm hopeful we're gonna find some good stuff. And this is some stuff that we found last week, right down the road. This giant moth was in a picture earlier that it stopped by to kind of sip some soda and meet us up close. We got some adult antlions. This is that Elyotes beetle that, again, Deborah had mentioned earlier, with the fused elytra that doesn't have functional wings. And we had a lot of other, this is a hairy scorpion, I believe, and it's not radioactive. They actually glow like that. There's a substance in their exoskeleton that reacts to UV light, and it creates this glow. And it's actually out there on the table if you guys want to take a look after this. But we got crickets and wasps and beetles, ants, moths. We got all sorts of things. So it was really exciting for me, not being from this area, being from New England, where, you know, there's greenery and you expect to find things, to see how many different things were coming in, even just in a night. So this collection is made up of things we found locally in a couple night collecting events, a couple day collecting events. And that's out there as well. And let's see. This is just a reminder that, you know, there's life all around us, which was the exciting part for me at these night collecting events. It's even in the desert, even in the summer, it's just sometimes not so obvious. And it's often easier to see if you're looking for it, right? Like the galls on the creosote outside. So this first photo is from a tree on my block in El Centro. There was just a little crack in the bark on the trunk, and I took a closer look to see if there was anything inside, and there's this cluster of eggs. These are some flowers from a neighbor of mine, and, you know, just one afternoon in the dead of summer, right? We had this little butterfly and the honeybee that I posted earlier. We have oleander lining the sidewalks in El Centro, and in the evening the milkweed bugs are just all over that. And, you know, if you go to Buckland Park at night, along like that open cement structure kind of by Ross Avenue, they're just crickets everywhere.
You know what kind of eggs those are?
I don't, I mean, there's just,
We have
mm-mm.
oh, okay, we're still trying to
you know, so there's life everywhere, and it's amazing, and it's interesting, and it's beautiful, and it's worth looking for. So Deb and I want to say a big thanks to Kristen O'Lear and the entire museum team for hosting these events this weekend. It's exciting professionally to be a part of it, and also as a new local resident. To be able to take part in this incredible resource for local, historical, ecological, and environmental understanding and knowledge. And thanks to all of you for being here and engaged tonight and interested in supporting and taking advantage of all the great programming going on here. And we hope to see a lot of you tomorrow night. And I think with that, we'll transition into some questions, or if anybody has them. Yeah.
As entomologists, you guys have like a favorite bug movie? Like Pixar, you know what I mean?
Oh, I was thinking The Fly, but.
Yeah, like in a proper way. Documentaries.
Ooh.
Yeah, so the one that I always go back to is The Life in the Undergrowth, by David Attenborough.
I really like Microcosmos, which is old at this point, but the photography is amazing. There are a lot of insects in that. Anybody else? We could kick the lights on.
The large moth, a particularly beautiful moth and the collection along with that. Can you talk a little bit more about that?
Do you know which one that is?
Yeah, so it's that type of center community. It's actually found outside of my home. We found it in our yard. In the I live in Alpine in San Diego County. It's a little higher elevation, but that one is a local species that's found here. Yeah, it's related to the same type of moths that they use to produce, that they have domesticated for silk. I know that some individuals in that group, the female, at least for the ones that are domesticated, the female is flightless. She can't fly. Her wings don't function very well. Yeah, they're really pretty. Yeah.
Oh, we were arguing whether that centipede or whatever that is, if it was real or not.
In the display.
Uh-huh.
Yeah, that's real. That one was found.
It looks like it's plastic.
Yeah. That one.
They're so cool.
That one again is a. Yeah, it's a native. That one I found in my yard as well. It's in the genus Scolopendra. There's several species of Scolopendra. But yeah, those ones, they serve their purpose as well. They're carnivorous, so they eat other pests. So they're good to have around. But unlike millipedes, they do have venom. They have fangs that, can bite you and inject some venom, and that's how they consume their prey. But yeah, that bright blue is really pretty. It's real. Everything in that display is real.
What's your view of cockroaches? Do you recoil like
No.
do, or do you find do they have a value?
Yeah, I mean, like I said before, I think everything has a purpose, whether that be, okay, so for cockroaches, one of the things that I tell people is the ones that we see around here, the pest ones, those ones are adapted to living around human structures. For the most part, the majority of species in the environment live in more natural habitats, breaking down organic matter, consuming waste, and things like that. The ones that we see here, we consider dirty, because they're consuming our waste, the waste that we've produced. So these cockroaches all, consume that organic matter, but yeah, the species that we find here in our homes and around our homes are just adapted to that type of product.
You're living with what do you do?
I just grab it and throw it outside. Yeah. I was growing up, I was the one that, people used to call, whether that be in the classroom or at home, Debbie, come get it, and throw it outside. I have a soft spot for roaches. I don't know, I think they get a bad rap, and take a look at their faces, they think they look pretty cute.
It's amazing to me how well they can fly, the full mature American cockroach.
Yeah, they do. They're pretty large. Those wings are pretty big. Yeah.
Therapy sessions for wind scorpions. They're my bane here.
Oh, really?
Yeah, like you get them into a corner and they're like they come at you, man. They're
Yeah.
not afraid of a good interaction.
Yeah, they'll try to defend themselves if they're cornered.
It's under,
you
yeah.
know, Yeah.
Because I try to catch them, take them outside.
Okay.
And they're always like.
Yeah, with those long
They're so
pedipalps.
fast.
Yeah.
That's, oh my gosh, like between the two of us, we're like hurting it. It's like
Mhm.
hurting cats, trying to get it.
Yeah, the ones, I was out camping here in the desert one night, and a friend of mine has a fear of them as well, and she thought it was chasing her, but what it was actually doing, it was trying to hide, so the fire was producing a shadow, and it doesn't recognize that you're a person, it just sees a shadow and it wants to hide, and they're so quick, so she was running away, and it was chasing her shadow. Yeah.
Does the Arizona blister beetle, they actually blister your skin?
Yeah, so that the beetle that I showed there belongs to that family of beetles, Meloidae. Those are commonly termed blister beetles, and they produce a substance, cantharic acid, that is caustic and will cause blisters. Yeah, so I wouldn't handle those. It happens mostly when they get crushed. You know, if you're just handling it, I guess I suppose it's okay for it to walk. It's not feeling threatened, but if you squish it or something, then they'll emit that.
Come across this twice, I think, in the period of their names, all over everything,
Mm.
bushes and rocks. And
Uh-huh.
they're incredible beetles.
They are.
Orange, red.
Yeah. So some of them, if you'll notice the one that I had in the picture, its actual cuticle is black, but some of them will have a white substance or yellow or orangish substance that's on their exoskeleton, and that's some kind of secretion, some kind of nitrogenous secretion that they produce also as a defense. Yeah.
So what kind of a shock was it to move here from New England?
Oh, I moved in early May.
Yeah.
It's still a shock. I haven't worked my way out of that yet. I hear November's nice.
Yeah, it could be nuts.
Yeah, yeah.
You had a question?
One of my favorite parts out here is definitely got to be French.
Yeah.
I remember the first time I actually saw one of those was literally carrying a tarantula back.
Oh, okay.
Can you possibly speak about those?
Yeah, so this one that I showed in the picture was hanging out on the buckwheat. Those are the large wasps that are black. Again, that aposematic coloration, black body, brightly colored wings. Those ones have a very painful sting. I haven't been stung by those personally, but I have some colleagues that have accidentally. But yeah, what they do is they'll fly around in search of spiders, tarantulas, and they'll inject venom, which paralyzes the spider, but it keeps it alive. And they'll take it back to its nest where it has larvae, and the spider is food for the developing larvae.
Are there cicada killer wasps? They have a very similar kind of
Yeah, same thing.
life
Yeah.
with cicadas.
Yeah.
They're
Uh-huh.
here too.
Yeah, there are other a lot of wasps in that group that do the same type of behavior.
So the larvae actually, are they injected into the spider then, or are they just eat it from the outside?
No, they're just consuming it. Yeah. Yeah, they're really beautiful wasps. So. You're right. Yeah. So I mean, we encourage you guys, if you haven't already, to check out the table. We just added some cactus pads with the cochineal scale. I also have a scarf out there that's been dyed with that substance. In the flyer where I'm, holding up the sign, I live entomology. You'll notice the pink shirt I'm wearing was also dyed. Yeah, so there's some books out there that we have that I've used for my purposes, ID guides. Just encourage you to take a look at what we have out there. I also grabbed some of those galls from that creosote bush, and I have them on display there. One thing I forgot to mention too about those galls, the newly developed galls will be a bright green. They may be a little harder to spot than the brown ones. The brown ones are old, the fly has already emerged and they've dried out. So next time you're out, I'm sure you'll spot the brown ones. See if you can find a fresh skull. Those ones are harder to find. They blend in with the plant a little bit better.
Debbie, you
Yeah.
said you have a particular interest in the harvester ants,
Yeah.
so I'm gonna tell a story.
Okay.
Debbie and my daughter actually were classmates at Southwest High School and at Imperial Valley College. I've known Debbie for many years, but my daughter and her husband live in Cicada, New Mexico. And we visit them periodically before the pandemic. I haven't been there for a couple of years, but in the home they were living in at the time, one time I went there, there was a large ant colony in their backyard. And so I saw that ant colony, and growing up on a farm like I did, and assuming my daughter had the same mentality, I said, oh, now you have ants. I said, remind me next time I visit to bring ant poison. And my daughter had a shocked look, and she says, no, you won't. Debbie says those are bearded harvester ants, and they aerate the soil, and she went on and on about all the things that those ants do. So anyways, I didn't poison her ants. So.
You wanted to, though.
Well, it's just the way I was raised. Yeah. Get some poison put on the ants.
The property that I live on now has about 15 different nests of harvester ants. And when I arrived there, I noticed that the previous people had been trying to do that, trying to get rid of them. And we haven't been stung. I think my fiance has been stung once, but he wasn't paying attention. He was wearing sandals and standing right next to the nest. One of my goats got stung one time, but in the 3 years we've been there, they haven't. I mean, they just go on about their business. Sometimes they'll form highways through the grass, foraging, and I don't know, they're really fun to watch. I enjoy watching them.
What was really interesting, Debbie, is one, we visit there usually like Labor Day weekend, which is monsoon season in eastern Arizona and New Mexico, and they were having a great deal of monsoons. And it just poured all night long, and the backyard was flooded, and this anthill was, maybe it wasn't underwater, but there was water going down into the colony. And I thought, oh my gosh, they're all going to drown. And then the next morning when it cleared up, here they were. They were all working away, clearing out their colony. And like you said, they, after I was scolded about not destroying them and enjoying the fact that they were there, they were part of the environment. And of course, they had their little. You've been there. You've seen their.
Yeah. Yeah.
They have their little house, bat houses, and so you had a great effect on Angela. Bat house and insect house, and they're recycling, some of the waste, and they have their garden. But the ants were very industrious. They cleared out their colony, and they went back to business as usual. So it was quite interesting. So it's nice to see it from another side of not just an agriculture side, and as a pest.
Yeah.
Seeing what part they play in the ecology there.
Yes. So regarding the rain, if you're curious about that, so looking at the structure of the nest underground, of course they have a tunnel, in the center where they go down, and they'll have channels under there that go in, different chambers for different things, for the larva, the brood, for seed storage. But the tunnels are not straight, so they'll be curved upward. So if you think about it, when the water's coming in, it may pool here, but it's not going to reach those stores that are. So if you can imagine that, if you can visualize what I'm saying, they built it in such a way to protect it. Yeah. And then they'll also cover the nest as well with stones, sometimes during the heat of the day or in temperatures like that. They'll put different stones or sticks to kind of protect that opening as well. Yeah. They're very smart.
The lizards and their horntails.
Yes.
Horntails.
Yes.
That's what they eat.
Yes. That's correct.
That's
Yeah.
the entire diet.
Yeah, that's correct. That's their main food source. Yeah, and that's one of the concerns too there's a different ant, you guys have probably seen it. Argentine ant, it's a full black ant that you can find in your home or your garden. It's native to South America, but it's invaded the US. It was thought to come in here on ships carrying coffee that had soil as kind of like the insulator for the coffee. And of course, soil is not allowed through the border now because now we know it can harbor nests. But yeah, these ants are here and they have displaced these harvester ants in certain areas. And that's a concern for the horned lizard. Yeah, there's a fire ant as well from similar area. Yeah, I could go on in a separate presentation just about ants.
Any final questions? Once again, thank you so much